my honor to introduce the fifth Son震Chair lecture, Nobuhiro Kiyotaki. And he is a Pritzker professor, and he has been known to show how small things matter a lot in macroeconomics. If you ever think about Keynesian economics, the multiplier is one of the key components. And Nobu has showed how monopolistic competition is the key founding component or the micro foundation of that. He has also showed with Randy how money can solve the double coincidence problem. Again, a small thing can have big effects. So let's welcome Nobu.
Thank you very much for having me here. So this is a paper with John Moore and Shen-Xin Dan. And this week I'm staying in the economics department. So feel free to stop by too. And I'm giving talk today as well as tomorrow. And so this paper is about the funding horizon and interest rate and growth. And the question we ask is recently many business, the intangible capital become more important than tangible capital for production as well as for valuations. And the intangible capital is very unique because often the continual effort of key worker is essential for development as well as the maintenance of the business. And but often these key workers are not staying in the same farm forever. They can work for somewhere else. And so the question we want to ask is how to finance investment when this continual effort of key worker is essential for development as well as maintenance. And if key worker cannot commit to provide the effort in future, and how that affect the horizon of funding horizons, and how this funding horizon interact with the plant dynamics of plant as well as aggregate economy. These are the questions we want to ask. And before going to the full model, the fully developed framework, I will give you the little example. So this is like a Mickey Mouse example we call. And but sometimes you shouldn't underestimate the power of Mickey Mouse because this is a little example. So suppose the key worker we call engineer has investment technology. They can put together the building as well as general fund we call goods to construct the plant. And by this investment, also they acquire the human capital for the maintenance. And the human capital, you can think of this as learning by doing. So the typical learning by doing is learning by producing, but here the learning by investment. And when you look at the seminal paper by Ken Arrow, actually he used the learning by investment, not the learning by production. So we used Arrow's style, learning by doing. So when you put the goods and the building, you get the plant and the human capital. Okay. Do you see the? Feel free to interrupt so for clarifying questions and devastating questions, please hold it until the end. How to finance this investment? Partly your own money, but for external financing, engineer is going to sell the plant to the saver. So you can think of this as equity financing. So ownership of the plant is sold to the saver who have money. But something which you cannot sell is a human capital. So you cannot enslave yourself. And so you have a freedom to work somewhere else too. So the raising fund is against the plant ownership, not the human capital. That's the financial friction we are emphasizing. This is based on the earlier work of John Moore. So this is the investment technology, putting the goods and building to construct the plant. And through this investment, engineer acquire the human capital for the maintenance. And the plant you can sell, or you can raise the fund 100% against it. But the human capital you cannot raise because you cannot sell it. And that's the financial friction. And John Moore and Oliver Hart has an earlier paper called the Theory of Debt based on inalienability of human capital. This is using that idea, actually. And then, so if the engineer continue to put the effort to maintain this plant, output will come. And for simple example here, it's all or nothing, actually. So as long as the engineer is going to put some effort to maintain this productivity of plant, output will come YT plus 1, YT plus 2, and YT plus 3, and so on. But once, if you missed once, then productivity gone. So interruption is fatal for this plant productions. And a lot of production is like that, actually. If you fail to maintain, it's gone. So that's our technologies. Okay. And here the match between the engineer and the plant owner can change. So engineer can work for some other plant, as well as plant owner can hire new engineer too. But this period, it's 1-to-1. So within this period, they are just watching each other. So this engineer is the only one who can work for this plant. And then this plant is the only place for engineer to work. So, but over time, next period, they can move around. So that's the example. And the key friction is engineer cannot commit to stay in the same plant to maintain this plant. So that's the situations. How to characterize these situations? One way to do it is the bargaining. So plant owner and the engineer bilaterally match this period. So they are going to bargain over how much pay to the engineer, wage. So this is a surplus for the plant owner. This is the VT plus 1 is a continuation value of the plant from next period. So present value is 1 over 1 plus interest rate, gross interest rate of the next period value. That's the value at the end of this period. And by paying the engineer W, this is the surplus for the owner. But the concerning surplus for engineer, it's just today's wage. The reason is if you have seen some matching model of the labor, often what we have is the continue to employed minus value of unemployed. That is there. But here the engineer can find another job next period easily. Therefore, that gap doesn't exist. Therefore, the surplus for the engineer is just today's wage. But the surplus for the plant owner is actually continuation value of plant itself, because of once you miss the maintenance, it's gone. So it disappears. So the stake for the plant owner is much bigger than the stake for the engineer. Do you see the situation? And then this is sometimes called the Nash product. So basically, the surplus of plant owner times the bargaining power of owner, and the surplus of engineer times the powers of the 1 minus theta, bargaining power of engineer. So if you maximize this with respect to W, you can solve the W. So it's like a Pythagoras. So it's like a theta divided by 1 minus W plus this guy is equal to the 1 minus theta of the W. So that's the first order condition with respect to W, and which maximizes the Nash product. And then when you solve with respect to W, what you get is the engineer's wage is the 1 minus theta fraction of continuation value of the plant. So they get the 1 minus theta bargaining power share of the continuation value to the as a wage. And then when you think about the value of the business for the owner, today's output is already coming, but you have to pay wage, and then continuation value is this. So this is the value, expression of value of the plant. Okay? So, but when you put this equilibrium value of the wage of the engineer, you can see this one 1 minus theta fraction goes to the engineer. Therefore, only theta fraction the owner retains. Then when you repeat this one and iterating, what you get is the value of the plant is today's output, and then present value of theta fraction of the tomorrow's output. 2 periods later, it's theta square fraction. And then when you look at these expressions, you see is it too big or too small? Is it okay? So this is like so it's value to finance investment. This is the value of the plant, and you can sell this today's the price B, which is the present value of that continuation value from tomorrow onward. So, but the one expression, one thing you see is it's not the entire present value of output, and moreover, it's skewed towards the present because of the theta keep coming up. So therefore, for example, theta is 90%. 2 periods later, the share to the owner is only 90 times 90, 81%. And 4 periods later is like a 60-some%. So it quickly decays. And therefore, the raising fund, you can raise from mostly largely near-term revenue, not the distant future revenues. So this is sometimes people call near-termism, but actually often people explain the near-termism by nearsightedness or selfishness of the owners. But this time, this is coming from simple bargaining, which every period the engineer gets the 1 minus theta fraction of the continuation value. The owner gets only remaining theta fraction, and the theta keep coming. It's basically the external horizon of external financing becomes short. Not the 1 year or 2 year, but it's like related to these theta things. So if theta is, say, 90%, this average duration is like 10 years. And this part of business is forever. And discounted is probably less than 10 years, like 5 or 7 years something like that. So this is the coming from the limited commitment of the engineers. And the one interesting aspect is the farther the distance into the future, rather the share of the output attributed to the engineer's effort, so cumulative maintenance. So the owner's share is declining like theta square, theta cubic, and like that. And that means the engineer's share is increasing, 1 minus theta square, theta cubic, and so on. So this is like engineer's share keep rising, and the owner's share, plant owner's share is keep declining. And that's why engineer others, the owner is deriving the value mostly against the near-term revenue. And that means when engineer raise fund by selling the ownership of the plant, they can raise the fund only against the near-term revenue. And so that's the implication of these little examples. It's not, some of you might know the incentive literature. Like in order to induce the effort, you try to put the carrot in the distant future. And it's not like that, actually. The wage is more or less constant, but the fraction of output, which is attributable to the engineer, is increasing, while the fraction of stuff, is for the owner is declining. That's the implications. And but then what's wrong about this? In terms of maintenance, it's actually the efficient after investment. What is the problem is at the time of investment, because of the fundraising is against the near-term revenue, they cannot raise enough funds. So as a result, this limitation of commitment leads to the limited capacity to raise external funds, therefore limited capacity to invest. And when you have a limited fundraising capacities, the investment depends upon how much on net worth the engineer has, divided by how much does it cost minus how much external financing you can raise per unit. So this is like the down payment. So down payment, 1 unit of investment costs this much, but the B unit you can raise fund. Therefore, only money you need is this gap. But your money you have saved over the time is this one, then investment scale is limited by the ratio of the net worth they can prepare versus the down payment you need per unit. So the question is so this little example is telling you why the if engineer cannot pre-commit to work for to maintain the production facilities, then the funding horizon gets shorter because of every period engineer capture the 1 minus theta fraction of the continuation value, and as a result, maintenance itself is maybe efficient, but the initial investment may be too small. That's the line of logic. And do you have any questions? Yeah.
So this example is very insightful. I think the source of, or say the magnitude of this financial friction, is it kind of highly relying on the assumption like there's no market for human capital?
Yes, yes.
So, like,
so you cannot
hire the next.
No. You can. I will come back to that point, but it's not not the market is not there afterwards, but actually every period you have to hire engineer to give the reward. And the engineers, the feature is that they can get some fraction of continuation value.
But the fact that there is no other engineers
Yeah.
that have the same human capital.
Yeah. I will, in the model, actually I allow the competitive market for engineer. Yes, it's there. And here the assumption is this period, this is the only engineer available. And as you said, that limits the market size and bargaining power determines the wage. But the full model, actually we allow you can hire anyone, even this period, not next period. And so then I will relate to this example and the full model. But one question is what determines theta, for example. And here it's just exogenous. But full model, we want to explain what determines the theta. So all these things. That's very good questions. And long time ago, I had my friend, who is a Japanese friend, who is terrible in English, and have an opportunity to give a talk in US university. And we told, okay, if you got a tough question, you just say, that's a very good question. And then he gave talk at Harvard, and somebody asked, what is x in your second equation? And he said, that's a very good question. And let me come back later. And he just continued. But anyway, so this is the introductory example. Okay, so let's go to the full model. So it's a small open economy with the exogenous real interest rate. R is exogenous. And then there is a homogeneous goods, and which can be used for investment purpose as well as consumption purpose. And then utility function is the present value of future utility, and we use the log as an example. So, and then each agent sometimes have an opportunity to invest. We call them engineer, and sometimes they don't. We call saver. And this state will change according to the Markov process with some persistence. So that's and then what do you mean by investment? Investment technology is basically this engineer, particular engineer E, they invest. So one building and X unit of goods, you get the plant, you get the 1 unit of plant with initial productivity 1. And also they get the tool. So this is the tool. It's a human capital, basically. 1 unit of human capital. We call it tool, but the tool is specific to the engineer E. That's why we call it E-tool. So that's the technology. And it's constant return. So you can scale up any numbers. Do you see? Okay. And then engineer raise the fund by selling the ownership of the plant to the saver who have money but who don't have an investment opportunity. And match between engineer and owner, plant owner, is not specific, not even this period. That's a difference from the initial example. So basically the plant owner can hire any engineers at a competitive wage. And the only commitment problem is engineer cannot pre-commit to work less than competitive wage. And initially, engineers have an investment opportunity. They want to raise the fund. And then one way to boost the fund, boost the external financing is providing, okay, I can maintain this plant for much lower price than the competitive wage, but they cannot do it. Basically, this is sometimes contract literature called the non-exclusivity constraint. Basically, people can trade privately in the behind the back of the principal. So that's the assumptions. And this non-exclusivity constraint includes the stock option. So you can sell the stock privately. So the one way to overcome this limited commitment is instead of paying in wage, period by period, you can give the stock option. But we take the extreme version of the non-exclusivity constraint, which is you can sell the equity at the privately, or you can find a friend to sell to that friend and the friend, and then you can raise the fund by doing this. So that's this non-exclusivity constraint. And then at each date, owner of the plant of productivity Z, initial one is 1, can hire any kind of tools, human capital, and to produce the output as well as maintain the plant productivity. So this is the technology, like initial productivity Z, and they hire H unit of engineer or tools. Then what happens is output is proportional to the plant productivity, and A is the aggregate productivity. So that's the output. But then next period, lambda fraction of plant continues, 1 minus lambda collapse. So 1 minus lambda is the depreciation rate of the plant. And then this remaining plant has a productivity which depend upon Z, today's productivity, as well as H, which is a maintenance effort. And this production function is sometimes called the roundabout production. Basically, the H enters, and then next period, productivity is Z prime. But tomorrow's H come in, the 2 periods later. So eventually, like a cumulative effort determines the productivity. And the impact of initial productivity decays with factor theta square, and so on. So this is instead of assuming the bargaining power, we relate to the technology, basically. And if theta is 1, and eta is 0, then it's exogenous. Productivity is exogenous. And we assume the human capital also depreciate by factor lambda. So that we keep the depreciation rate same across the tools as well as plant. So that's and the heart of the paper is this production function, actually. So we basically put everything into this production function and then to derive the results from there. Do you see that? Are you okay? Or feel free to interrupt and please.
No.
Yeah.
Can I ask a question?
Yeah.
Suppose because I think the important assumption here is the human capital.
Yeah.
Cannot.
You cannot sell it.
Yeah. And also you cannot commit to work.
Yeah.
But suppose the engineer produces something like patent, and the company can use the patent for the future. So that, for example, the company can use patent as the collateral to borrow.
Yeah.
So would this affect the horizon of financing?
The patent case is it is like a initial productivity, but then the patent usefulness in this technology, actually the productivity of plant is not just a constant number. It's actually depend upon cumulative effort of H prime, and so on. So that's the different technology. So patent is more like an exclusive right of some stuff. Like it's more like a plant ownership comparing to the plant ownership. But here the productivity depends upon not just the initial productivity, but also continuing effort. So that's this technology. Yeah.
So following question. Suppose the human capital accumulate through learning and doing. Say if you not only accumulate, you can also accumulate human capital when you are working.
So they do accumulate. Actually, this is the accumulation technology. So through the investment, they get both plant as well as human capital. And then human capital part has a limited commitment problem, while the plant part, no. And the patent is more like this one, not something you can sell. And then the human capital is useful because it will affect tomorrow's productivity.
But if you accumulate enough human capital and you break up this relationship, then isn't you will give lots of human capital?
Yeah, human capital is going to be price is going to be determined by this competitive market, and then I will come back. But one possibility is actually initially the production, the plant and the human capital is 1-to-1, right? And then depreciation rate is both lambda and lambda. So if no plant stops, then plant to human capital ratio is 1-to-1. And if it's 1-to-1 and the start is 1, the productivity continues 1. And so one equilibrium, which we call non-stopping equilibrium, the ratio constant, and then productivity stays the same level, which is similar to the initial example. And but the alternative exists, and some plants shut down, and then ratio of plant to human capital to plant is no longer 1-to-1. Then other things happens, but I will come back to that one. So, yeah.
I'm just wondering what if the plant owner can set up some punishments if they observe.
Yeah. So that is like sometimes called the non-competing clause. Like you cannot work for somebody else for a limited time. And again, we are going to take this non-exclusivity constraint seriously. Basically, the engineer can work for anybody, and nobody can stop because the engineer is almost anonymous. And so this is not the engineer you think like Elon Musk or famous people. It's actually the engineer, like thousands of software engineer or data scientists. They keep moving around. So you cannot identify, and also you cannot prevent one person working for somebody else.
So the punishment that I'm thinking about is like suppose that you leave, then the engineer has to pay some fee.
No, this is the inalienability questions. Basically, they can disappear. and somebody try to chase you. You go to some foreign countries and under different names and that sort of thing. So, yeah. So this is no exclusivity constraint. Okay. So where is the building come from? It's supplied by foreigners. You can make the construction industries, but that makes a little harder to keep track. So just for sake of the focusing plant part, we assume the building is supplied by the foreigner, and then foreigner has an alternative use of building, which is building will get some constant output, and depreciation rate is lambda 2. So this is like a parking lot, and the foreigner can run the parking lot to get the output here. And then if you have this and the alternative use is elastic, then the price of the building is determined by parking lot revenue. So this revenue every period per unit divided by the gross interest rate minus the 1 minus depreciation rate. So some of you might know my earlier work, credit cycle. There actually alternative use F is endogenous, and more people are investing and less people are using the parking lot. Parking lot F is going up. So that will have an extra kick to the Q. But here we only have an elastic supply of the building. Do you see? Okay, and then this is a plant owner's choice. Plant owner, we allow the plant owner to stop and liquidate the building, the plant into the plain vanilla building, make it a big parking lot. And then this is the value function. So value of the plant at the initial productivity Z is today's output, which is coming. And then after production, the people can choose whether to liquidate as a building or you continue. And the continuing case, you hire workers, the engineer, at the competitive wage rate W. And then how much engineering input you hire affect tomorrow's productivity. So this is like a productivity, and the lambda fraction of building stays, the facility plant stays. So this is the present value. We are mostly looking at the steady state and here. And so that's the endogenous choice of how to maintain the plant. And this kind of problem, actually, you have to look forward. And if you think continue forever, you want to maintain properly. But if you are planning to stop, then you don't hire engineer much, only for next period production purpose. And then this period, if you stop, of course, you liquidate right away without hiring engineer. So that's the plant owner's choice. And how much the engineer can raise fund is the initial productivity is normalized to be 1. So that's present value is the fundraising capacity P. So that's the external funding per unit. Do you see that? Okay, and then what's the individual's choice? So engineer at T, so this is a consumption, budget constraint, and this is investment. How much does it cost? It's goods cost X and the building cost Q. But per unit, they can raise fund external fund by B. So the only money you need is a gap between the investment cost and the price of the building, price of the plant at the beginning. So external funding. So, and then you can buy the financial assets too. So, and you don't have to sell 100%. Then that's part of them is considered to be financial assets. So, and then how do you finance this expenditure and saving? It's partly return on the wage income of the engineer, if you are engineer, and partly coming from the financial assets saved from last period. And if today is agent is engineer, H is positive, and it's positive if engineer have a H today. So yesterday was engineer, and if you this agent is engineer today, they can invest to boost up the human capital. So because of the plant part, you sell to the saver. So therefore, what you accumulate is the human capital. Of course, you can keep some plant ownership as a financial assets too. But the financial assets, plant ownership, and internationally traded bond has the same return, exogenous interest rate R. Do you see that? And this one you can rewrite as a gross way. So putting HT plus 1 here, then this is the consumption. This is the acquisition of human capital. This is the acquisition of financial assets. And then how do you finance is the wage plus replacement cost of the human capital. So this part you don't have to finance yourself. You already own it, lambda fraction. And then this is the financial assets. And the total is the net worth of the agent. Are you with me? Or for detail, you don't have to worry too much, actually. You can read the paper too. But you can get the guts feeling, and that's usually enough. So you don't follow every nuts and bolts in the first time. But what you see is if you have an investment opportunity and the investment return is higher than interest rate, then engineer wants to invest as much as possible because the return is higher. What's the return? The amount of money you need is the down payment, cost minus external financing. What's the return? Next period you get the wage as well as resale value or replacement cost. One tricky question is what happens if you become saver next period? And there we assume, going that way. We assume the engineer can sell the tool with the instruction. So that the tool is not wasted. But you can recover the competitive price is the same as replacement cost. Okay, and when you don't have and this is the consumption function. Actually, log utility is very convenient because can you see it? So if you have a log utility like this, and when you take exponential of that, actually it's the same as Cobb-Douglas utility function. You see? And Cobb-Douglas has a feature that expenditure share depend upon this coefficient. And the expenditure share of today's consumption is actually 1 over 1 minus plus beta beta square, which is 1 minus beta. So 1 minus beta fraction of the net worth is consumed, and beta fraction is saved for the next period. And then that's the investing engineers, the behavior. And savers who don't have an investment opportunity just save in terms of the financial assets. That's the framework. And then you can define the steady state equilibrium of small open economy. There are two prices, which is one is the wage rate of engineer, and the other is the plant price. So these are the two prices, actually. And by the way, this is not the wage of the regular worker. It's more like a wage of the key workers, not the routine workers' wage. So, okay, and then you have associated quantities, choice of savers and plant owners, and the foreigners, and and the market for goods and tools and plant and bonds, all clear. So that's the competitive equilibrium. How do you solve this stuff? Do you have any idea? So when you have a framework, what you do is guess and verify. And, so that's what we did, actually. So guess is nobody stops. That's the one guess. So no plant owner will stop. So this is a guess. And then the ratio tool to plant initially is 1:1. And then depreciation rate is lambda both. And no plant stops means the ratio continues to be 1. See the equal depreciation, no stopping. Therefore, human capital per unit of plant is 1. And when you put the 1 and the 1, you get the 1 again. So the productivity is continue to be the same level as the initial level. And so that's the no stopping equilibrium. But in order to have this equilibrium, we have to prove like your alternative use is not that good. So parking lot is not that profitable, and the building price is not too expensive. So then all the plant continues. And that's the, and then initial example is a special case. If the maintenance technology is theta versus 1 minus theta, and add up to 1, then actually the competitive equilibrium with no stopping and the initial bargaining model is identical. And some of you might see this is similar to Hossios condition. And Hossios condition is usually matching technology and unemployed and vacancies, and the ratio is like this. And then actually the wage rate through the competitive equilibrium is efficient. Or the bargaining, Nash bargaining is also equivalent. So that's what we have here. And so then what is unique about this, and what is the wage rate in equilibrium? After you try to understand the property of equilibrium. So wage is, when you look at this, the maintenance technology, and then competitive equilibrium without stopping is 1:1. So then the wage is the same as the present value of the marginal product of human capital. And remember, this is the choice of how intensively you hire the engineers. And then when you solve this guy, then the optimality condition is the wage is equal to the present value of the human capital. And the difference from the usual model is age affect tomorrow's productivity, but also through the tomorrow's dt plus 1, it affects the day after's productivity by factor eta times theta. So tomorrow's productivity is affected by eta, and the next 2 periods later is eta to the theta because of the dt plus 1 enters here, and dt plus 2 is affected by theta times theta. And 3 periods later, it's like a dt plus 1 affect, dt plus 2 is affected by factor theta square, and so on. So that's the expression of wage. And the wage is very forward-looking. It's not just today's marginal product. It affects long-lasting impact to the future. And when you look at the plant owners one, this is the present value of profit, output minus wage to the engineer. But when you plug in this guy into here, you can see the plant owner gets everything today, tomorrow, but there 2 periods later, eta fraction goes to the engineer. 3 periods later, eta plus eta theta goes to the engineer. So engineer's share is increasing while plant owner's share is declining. So this is a picture. So this is a horizon, and so output is here, and then owner's share is declining with the horizon. More distant future, the owners get the smaller fraction. See the owner's share decline from 1 minus eta, 1 minus eta, so on. And actually, eta is 1 minus theta. This is the theta, theta square, theta cubic, and so on. And so that's the owner's share. And the engineer's share is increasing. But this doesn't mean the engineer's wage is going up with time. Engineer's wage is still constant. And then you might say, at some point, owner's share is lower than alternative use. Why don't you stop here? And this is natural questions. And then answer is suppose the time goes from t to t prime. And then what happens? The productivity is still maintained here, same level. Actually, although the sum of the wage paid between these two, t and t prime, is contribution to the output in future, that part is already paid. So it's a sunk cost for the owner's point of view. So once you reach that point, owner's share is still this one, A prime, B prime, C prime, and this guy. So, and that exceeds the alternative use. As long as the output is higher than wage, you have a profit. And so you keep doing this because of the past wage is a sunk cost, even if it's a partly contribution to the future. And that's why you don't stop. You just continuous. Do you see that? And then what is unique about this funding horizon? And one experiment is the impact of exogenous change of interest rate. So here we use the slight deviation from perfect foresight. We just look at the perfect foresight steady state and then hit the unexpected one-time interest rate shock. And this is sometimes Tom Sargent called MIT shock, because MIT people often do these things, and which is very convenient actually. So let's do once interest rate drops and then permanently drops. What happens? Typically net worth go up. So which is we emphasize in credit cycle paper, net worth of engineer will go up a lot. But at the same time, investment costs go up. Q is high. And also fundraising capacity also go up. But the problem of that is if you look at the present value of F is the building price, while the present value of this declining one is the fundraising capacity. But the fundraising capacity, because of its downward sloping, the duration is shorter. So like a duration of external fund you raise is not the 30-year, 50-year, that sort of order. It's actually 5 or 10 years, that sort of order. So when interest rate is going down, actually the cost, part of the cost is building, which has a long duration, is going up a lot, while the fundraising capacity may not go up as much. Then paradoxically, investment can go down, so, which is kind of weird. Actually, if you think about the interest rate go down, why the investment go down? Answer is despite the net worth go up initially, but the investment cost may go up more than fundraising capacity. And what happened is initially the investment go up a lot because of net worth go up by unexpected the permanent fall of interest rate. But eventually the investment starts stagnating. But because of the investment costs go up more than the fundraising capacity. One intuition you can get is the housing market, for example. So housing market, suppose interest rate is going down persistently. Housing price go up a lot, right? But borrowing capacity may not go up as much. Think about the younger people, like they said the income doesn't go up that much, so the fund and the fund external borrowing constraint depend upon not just collateral but also cash flow. And the banker said, since your income is not going up that much, I'm not going to lend you that much. So then what happened is the old timer who already have an apartment think, wow, the going up is a good news. Housing price go up is a good news, and that part dominates initially. But the newcomer, youngsters, find the housing price go up more than borrowing capacity. They had a hard time to buy the first-time house, and eventually this starts winning. So what we got is a temporary boom followed by longer recessions. And the temporary boom, and the output starts going up, but eventually growth rate is slowing down. And I came from Japan, and the late 80s, everybody was excited about the high land value. And initially everybody is happy and euphoria, and the consumption go up too. But the problem is the newcomer had a hard time. And the real new investment. So most of the increase in value of investment is the cost is going up, and not the investment on plant and human capital, which is the engine of growth. This is the endogenous growth style model. So if engine of growth slow down, actually the growth rate go down. So what we got is the temporary boom followed by stagnations with permanent fall of interest rate because of the investment costs go up more than fundraising capacity. And so that's the one implications. Do you see but usually people say, wait a minute, usually low interest rate is good news. And the reason central bank and all these business people, low interest rate is good news for investment is typically the duration people think about the low interest rate is not the permanent one, but the 5 years low, later 5 years high. If the interest rate fluctuation is medium term, then yeah, the fundraising capacity moves a lot. While the building price depends upon 30-year interest rate, which doesn't move much, that is expansionary. But the danger comes with the yield curve control. So when you do the yield curve control and the interest rate is low for long durations, then building price may go up more than fundraising capacity, and investment and output can stagnate in this kind of situation. So that's the aggregate implications. Do you have a question? So, yeah.
So if we look at the down payment,
Yeah.
and compare with the
Fundraising cap-
paper with housing prices
Uh-huh.
and the credit cycle,
Yeah.
and the fundraising capacity
Mm.
is equal to the discounted the future house price.
Yeah.
In
Yeah.
the credit cycle paper.
Yeah. Yeah.
And so, is there a way
Mhm.
that in credit cycle paper also generate the problems?
The propagation, fundraising capacity in here is not against the building. Actually, the credit cycle, building is a collateral. And so they raise the fund by basically Q. And so only down payment you need is X. So then the net worth effect is dominating. And, but here the fundraising is against the future cash flow. So you are going to get the borrowing against the cash flow, and which cash flow belong to the owner. So it's like an equity financing instead of the collateralized debt financing. So that's the difference, yes. And but then when you rely on cash flow, but the owner knows they are not getting the return from distant future, mostly near-term future. Therefore, that is less sensitive to interest rate than the Q, the building price itself. That's the difference, yeah. How much time I have? Oh, you? 25. Uh-huh. Do you have a, okay, so do you have more questions, or is it okay? Oh. Yeah?
Is it right that one of the implications of this model is that the magnitude of underinvestment is highly related
to the importance of, yes.
between factors and
the technology, like how important is intangible.
So there
And
policy implication should subsidize the investment.
I don't know. I will come back for policy. Yes. But it does. How underinvestment does depend upon the importance of the engineering maintenance part. Yes. One question you might say is, you said the F is alternative use is less profitable than critical level, then everybody continues. But so what happens if it's the other way around? So usually when you build a model, you kind of, here is we thought what happening. So then, but for that you need the conditions. And then next question is if that conditions is violated, so alternative use is very profitable, what happens? Then society wants the smaller number of plant because of alternative use is very profitable. And then what happens in equilibrium is a mixed equilibrium, which is basically the plant owner initially indifferent between shutting down eventually versus continuing forever. And in that case, actually the tool to plant ratio is larger than 1 because of the tool decay is only factor lambda, while plant partly shutting down. So as a result, the continuing plant's productivity keep improving. So because of the H is bigger than 1. And then plant who is shutting down, productivity is going down. So this is sometimes called Zubigurikas and Regev has a paper about examining the Israeli industry. They identified something shutting down plant, the productivity slowed down before shutting down. They call it the shadow of death. And then that's what happens. And this is different from standard Hugo Hoppenheim or other people's exogenous process of productivity. This is productivity is highly endogenous, this kind of things. But the Hoppenheim style model, exogenous shock also exists. So we can look at a little bit of shocks, initial shock as well as continuing shock to the maintenance. It's largely endogenous due to the engineering input and the previous productivity, but the exogenous shock also comes. Then there is no like a mixed equilibrium, but not many measure of indifferent people is almost 0. So this is the plant dynamics. Basically, the plant productivity is high enough. You try to put a lot of effort to maintain, and on average, it's go up. But the productivity is low. You don't maintain much, and eventually, it's shutting down. And this red line is 3 sigma standard deviation, the shock region. So it does have this Markov-like situations. But so that's the alternative part of the parameters. But then nowadays the macro model, you still need some evidence. People often like all days theory is good enough, and like my paper with Randy, there is no empirical part, and even with John Moore, we don't have an empirical one. And when we had some calibration, we asked graduate students to do it actually. But nowadays the people say, what is evidence? And so the macro become more and more demanding. So we do. This is not our own work. We couldn't do it ourselves. So we find the two the empirical economists, the Angus Puris and Gabor Pinter at the Bank of England. The advantage of they have access to the data. And they have a very good access to the panel data of business. So it's like 80,000 the UK companies, and we dropped the tiny one, but less than 5 employees. But nonetheless, it's still huge. And then what we do? This is the tricky bit. And so there is a shock to the interest rate. And then some of the shock is endogenous, of course, reacting to the controlling inflation and that sort of things. But some of them are unexpected components. And we use the high frequency identification of the monetary policy shock. Basically, Bank of England has a scheduled meeting of Monetary Policy Committee 8 times a year. And then before the announcement and after the announcement, 30 minutes window, we look at the change of interest rate. And the change of the 1-year rate, 5-year rate, and also future. And then we try to look at the 1-year interest rate change, 5-year interest rate change, explained by this 30 minutes window one. And then we try to look at the impact on short-term interest rate shock to the short-term interest rate, and shock to the long-term interest rate. And then how do you do this theta business and importance of intangible capital? We are slightly bold. What we do is looking at the number of directors relative to the number of employees. So we think the number of directors, many of them relative to the size of employee, we call it intangible intensive. And we call it the funky company. And the reason we call it funky is when I presented Stanford, and Pat Kehoe said, "What is this funky technology?" and so we like that funky. So we decided to call the top heavy, like a lot of engineers, they are funky company. And then the other one called the non-funky. And of course, this ratio depends upon size of the company. So we divide the company into 10 size different categories. And within this size bin, above the mean, below the mean, above the mean, top heavy is the funky one. And the below mean is the medium, is the non-funky company. And then look at the impact of short-term interest rate, including the firm fixed effect. So this is the fixed assets growth rate over the 8 years. And then this is a growth rate expression like Davis-Hartwalker does. And then look at the regressions. So this is the regression. So 1 year horizon, how much funky companies reacting to short-term interest rate, non-funky one reacting short-term interest rate shock or long-term interest rate shock. One thing you notice is it's all negative, but the short-term interest rate, they are not significant. Especially for non-funky one, they are not that significant. Funky one does have an effect here. Not that significant, but it does decline. So 1% exogenous monetary policy shock to the short-term interest rate have a 7% decline of the investment in 3 years' time. But the long-term interest rate is something you get affected. And the standard theory said the company should react to the long-term interest rate shock. And the non-funky does affect. But the funky one is reacting less. And the gap is actually significant. So our theory says the funky company is raising fund mostly against the near-term revenue. Therefore, they don't react as much as the non-funky regular company against the long-term interest rate shock. And that's here. So you see the long-term interest rate shock, like a 12 to 13% investment drop for the non-funky, but the funky group is like a 9%. So gap is significant. And do you see this? This is like a funding horizon. You can try to effect on the investment. Okay, and you might say this is all coming from small companies. And yes, small company is reacting more to the long-term interest rate shock, especially non-funky one. But the gap is actually coming from not the smallest one, but middle one. So middle-sized companies, like employee like 50 or 10 or 50 or less than 100, they are the group who is reacting differently. So the funky company don't react much, while non-funky do react to the long-term interest rate shock. So, do you see? Okay, and then policy. This is the last one, sorry. And the policy implication. So one thing, the non-exclusivity constraint is a key, like a limited commitment and non-exclusivity constraint. Basically, the engineer can work for somebody else. And basically, the engineer cannot provide the maintenance service unless paid every period. Basically, it's impossible to keep track of these thousands of engineers moving around, including go to the foreign companies or foreign place. And but the plant doesn't move around, right? so it's easy to keep track the plant owner. Even if engineer is impossible to keep track because there are many of them and they keep moving around. So then what we thought is suppose the government can tax the wage bill of the engineer at the plant level. Even if the government cannot identify who are the engineer, they can look at how much wage bill they pay. And if you have that and use this wage bill to tax revenue, payroll tax revenue to subsidize the investment at the beginning, then actually the down payment is not the investment cost minus external funding capacity, but also the subsidy. And so if you when you have actually tax on engineering the payroll, the engineer's wage go down for them. But we can show actually the investment go up and the growth rate go up, and actually certain parameters everybody can be better off, and which is basically this is population weighted average expected discounted utility go up, and what's happening here is actually the government is almost acting like a creditor. Basically, they subsidize at the beginning of investment and later tax on the return for the engineer. So problem is engineer cannot pre-commit to work. But if you do the payroll tax, after tax revenue is lower. But then this tax revenue is used to subsidize investment, then it's almost like a government is acting like a creditor. Another group of creditor. So that is improving the welfare. But this highly critically depend upon the government can keep track the payroll actually. And then if government can tax on payroll, then you can improve the welfare. But everything else is almost impossible. Actually, we thought about many possibilities, but the non-exclusivity constraint is binding lots of place and hard to overcome. So this is the limited way to improve the efficiency. So I should stop here, I guess. So do you have any questions? Yeah?
I would like to go back to my previous question about although engineering cannot, the last slide.
Okay.
I mean, although the engineer cannot recommit, they can work for any plan.
Yeah, that's right.
Plan.
Yeah.
And this is inability of human capital.
Yes.
So think about different industry
Yeah.
that the degrees of inability
Yeah.
of human capital are different.
Uh-huh.
So that
So if we think the across industry difference is how important is engineer for maintenance. So this technology is different. Yeah, this guy. So this one. So across industry, what is different is eta is different, or theta and eta coefficient is different. So theta is 1 and eta is 0. That's exogenous, and then no problem basically. But eta is significant, theta is limited. Then limited commitment starts binding, and they have a under-investment tendency. Yes.
So go back to the data you found.
Yeah.
If you can,
Yeah.
for example, divide the
subsidize.
data into companies with different eta,
Yeah.
would it give
It
you
might have
other
yes.
evidence?
Yeah, it might. But yes. Yeah, it may be, yes. So you have a different tax rate, or subsidy rate. Some of the industry which has a lot of limited commitment problem, you subsidize. And yes, that's possible, yes.
I have a question
Yeah.
regarding the definition of funky versus not funky.
Yeah, this is very funky actually.
We just defined it as the number of directors
Yeah.
versus the employee.
Yeah.
But who, like for the first specific human capital, I saw like the top guy, human capital can be applied to almost all other.
Manager. So, but remember, these are not that big companies. So majority is less than 50 employees actually. So then this is like a pub mom shop sometimes. A little more than that. They have a extra employee, at least 5 of them. But the top heavy is there are few important key workers. While the top is not many, is the not many key workers.
I guess my point is like the lower worker, their human capital is more firm specific.
Okay. Yes. This one is more like we assume the human capital is general. Yes. And if the human capital is partly firm specific, result have to that point part. You can basically commit. Basically, by moving, you lose. The wage is not the same as the marginal product, but also less than that could be. Yes, yes. That might be related to this. We try different alternative measure of the funkiness. For example, we did try a wage. So instead of the number, we used the wage bill of the director divided by total wage bill. Result is qualitatively similar, but not as strong as before. And we also look at the different industry. So related to Itin's questions, the industry which you see the difference is manufacturing and also wholesale and retail. and also real estate. Real estate is not the actually the real estate developer, or that this is the real estate agents actually. So have lots of local knowledge and that sort of things. And so these are the industry. While like construction industry, there is not that significant difference actually. So broadly speaking, yeah, the wholesale, retail, manufacturing, and the real estate agents, it seems to have some importance of the intangible capital there. Do you follow me, or is it already? There are a lot of materials, I have to say, and so yeah.
In one of the slides, you show that even firms have higher productivity.
Yeah. So this is the case which people are this one. So this is something like a continuing farm try to improve while the shutting down farm become lazy in maintenance, and that's kind of propagations like so that's here, yes.
Under low interest rate environment,
Yeah.
saw in Japan as well, that there are firms with low productivity, zombie firms.
Yeah. We cannot explain the zombie effect, but we can explain the like a heterogeneity. Actually, some parameter space, if interest rate is high enough, equilibrium is pure non-stopping. Everybody try to continue. But when interest rate is getting low, like building become more expensive, actually not every plant continues. So then you get the dying people as well as improving people. So that will be a part of the implications.
Yeah, so because time is up, we'd like to thank Nobu for this wonderful talk. And for the faculty, there'll be continued discussion in 505G, the Public Economic Conference. Thank you very much.